So we're going to see if we can't figure out kind of a nice general formula for how wide or how much area we're going to have in this and how long it's going to be for a given width. So Moose is going to get a playpen and we're going to see how big it's going to be. The first one here we kind of did by hand. We said, all right, if we had one side of it was five feet long, then, well, our playpen is actually going to have two sides. So 2 times 5 gave us 10. We had 160 feet all together, so subtract that, that leaves us with 150. And we got to divide that by 2, and that gave us 75. But it's kind of a pain to have to keep on typing in that formula again and again. So what we can do is we can figure out the length as a function of the width. So let's kind of back up to what we did here. We took our 160 minus 2 times the width, and the difference between those two things we divided by 2. So there's a nice formula for that. Now you could plug this into Desmos or to Google Sheets, whatever works for you. But it's going to be nice to plug it into Google Sheets, or I mean to Desmos, because I get a nice pretty graph out of this. So let me do that here. If you wanted to do this in Desmos, so you get a nice graph, you're going to click the plus button here and add in a table. All right, so table, the x values are going to be our lengths. For the width, I want 160 minus this divided by 2. So let me type in 160 minus 2 times x. And then when you type a number 1 right next to that, it's going to automatically put it in as a subscript. Click and drag over this to highlight it all, and hit the slash key, divide by 2, and great. Now I can dump in any numbers that I want. Let's do the whole thing. 5, 10, 15, 20. And it kind of gets the pattern here, so it's going to keep on going all the way down. And I guess I should be going by tens, right? Yeah, at least according to the book. So let me just go back here and do 20, 30, 40. Because I was getting like impatient. I'm like, boy, I got a lot of these to do. 70. How come I'm going to stop here? Yeah, because after this, they're going to start getting negative. You're using more than you have in terms of fence. So I can get rid of these. Yeah, you're using too much fence at that point. So the cool thing about this is that if I want to see where these points look like, you hit the plus key over here on this magnifying glass, and that should dial things in pretty nicely. Okay, I expected a different looking graph. Oh, I guess there's one more thing that I'm going to want to do here. I'm going to want to find the area of this thing. So how do you find the area of a rectangle? Length times width. So I'm going to do length times width. That's going to give me, in the first case, 375. And let's see what happens. Any predictions? Does it matter which way I do it? I mean, I got 160 feet of fencing. Does it matter which way I build these things?
No.
No? Okay, let's find out. We want to make Moose happy, but it might not matter. So maybe we'll give him something long and narrow. Maybe we won't. Now I think I can do this here. Let me see. Let me call that y1 equals. No, it's not going to let me do that. All right, so let's do x1 times all of this, if it'll let me do that. I'm hoping it will. No, stop. Not letting me do that.
In the actual area.
There we go. There we go. So this is the area now. I just put it in another box here. Does the area change depending on the dimensions here?
Mm-hmm.
Yeah, it actually does, right? What dimensions seem to give you the biggest area?
40.
40 by 40. So let me copy these values down. Actually, I'll do that later, I suppose. Yeah, I'll do a couple of them. 700, 1200, 1500. All right, so 700, 1200, 1500, 1600. And then it's symmetric on the way back down, right? 1200, 700, 375. So certainly you want to choose something here in the middle. Probably this one's going to give you the biggest bang for the buck, right? At least for moose, if you do 40 by 40. Nice. If you were to graph this, what's that? The last one, yeah, last one should be 0. Must have miscopied something someplace. Oh, that's because these aren't symmetric points. Here, let's do this. Let's do 75, and then do 80, and that would be 0. Thank you so much. Nice fix. All right, so yeah, this would be 75. It's just kind of the flip side of this. Let's graph this and see what we get. So let's see, 5, 10, 20, 10, 20, 30. I think which way I want to graph this. Let's see. 10, 20, 30, 40, 50, 60, 70, 80. Okay, so 10, 20, 30, 40, 50, 60, 70, 80 is going to be right here. Now, if it was 0 feet wide, and I don't have a 0 here, but if I had a 0 there, then I would get 0 area. So I'm going to have a 0 here and a 0 here, as Nadal pointed out. Thank you so much. Area, I need to go up to 1,600 feet. So what scale can I do to get up to 1,600? 2, 3, 4, 5, 6, 7, 8. If I need to get up to 1,600, what should I scale things with on the y-axis? Yeah, 200 would be good. So I'll start here with 400, and then this is going to be 800, and then skip one, and it'll be 1,200, and then 1,600. So let's plot some points here. 10 is going to go up to 700. So that's going to be right here about. 20 is going to go up to 1,200. So it's going to be right there. 30 is going to go up to 1,500. So it's kind of slowing down. And then 40 is going to be up here at 1,600 and then back down. What are you noticing about this? Have you seen this shape someplace else today? Yeah, our Angry Birds thing. So 70, we're back up to 700, so nice. It's the shape of a parabola. And parabolas, depending if they're opening up or down, are either going to have a maximum or a minimum. Nice. So based on the graph, what makes the area as large as possible? Yeah, 40 by 40. So 40 for your width and 40 for the length. So that's your maximum, 40 by 40. What's the largest possible area? 1,600, and that's in square feet. Remember, there's one thing that I asked for you on your tech assignments, and that is for you to include the actual X and Y labels on your graphs. Describe the shape that the play area should make to make the area as big as possible. If it's 40 by 40, what kind of a shape is it? Square. So for a given amount of material, if you have to have things in a rigid way, then a square is going to give you the most area for your perimeter. If you don't have to have it in terms of nice rigid ways, then a circle would probably be your best bet. We're Write an explanation of the process used to calculate the length needed for each width. We did that up here. We just took the overall length, subtracted twice the width, and divided by 2 to get individual length. That's more of the same. Write the formula for the length and width of the triangle. Once you have the width, then we already got the formula for the length. It's 160 minus 2w over 2. Okay. Let's look over at page 541 here. Got some profit going on for a company that manufactures wind turbines. Can anyone interpret what that would be right there? What's going on there? Yeah, it's like your startup costs. This is how many kilowatt hours you're selling. If you don't sell any, you're out of like $50,000 or $60,000. And then you don't want to sell too much. You flood the market. You're not making enough money. Then you start losing money again. Now it looks like there's some intercepts. These are your break-even points. How much electricity is needed to be generated in order to make a profit of $100,000? You could answer, it looks like 70 here, but there's another answer as well, right? There's another one over here, maybe 380. So, about 380 or 70. 70 or 380. And that's in millions of kilowatt hours. That's a lot of electricity. What's the maximum the business can earn? Where do you think I'm going to find that maximum? Right up here at the top. Vertex, yeah, it's called the vertex. So what are we looking at? That's $225,000, so halfway between there, maybe about $237,500. If you just take the average of a couple of these numbers. So not bad, not bad. Here's the actual function that describes how much profit you can make. And you can plug in some values to try and verify some of these things here. All right, I'm running out of time, so let me stop things here and let a few of you go.